Okay, so we'll go quickly through, and for some of you who are in the training this morning, some of this will sound a little bit familiar, and for those of you who weren't, hopefully it makes sense. Stop me at any time, but I'm just going to try and blast through a lot of stuff, and would welcome any comments or feedback as we go through it. So in addition to being at UMass, I also am founder and CEO of a company. And as I mentioned in the training this morning, this creates all sorts of nightmares in your academic life. Ranging from having a very complicated document governing my behavior, which stipulates, first and foremost, that whenever I give a talk about anything, I must show this slide. So I do stand to direct benefit from the development of this software. The fact that I don't currently benefit in any way from the development of the software is not relevant. The relevant fact is we are commercializing. And back when I first got to know Nosh, was at the digital government meetings, we used to have a panel often on tech transfer, and they always said it was hard. But they never really fleshed out just how hard it is for a professor to start a company and commercialize inventions. It's really very hard, very complicated. And so we're really not quite sure what will come of it, but I do have this conflict. And I acknowledge the fact that I benefited from this partial list of the grants that funded the research that led to me being here and the development of this software. Originally, I found a collection of about 30,000 public comments to the National Organic Program in the USDA online, and then someone handed me a piece of shrink-wrap software and said, why don't you try this software? The software was called NUDIST, Non-Numeric Unstructured Data, Indexing, Searching, and Theory Building, a precursor to NVivo, and similar to Atlas TI and other qualitative off-the-shelf packages. And I got my first grant to see whether or not the federal government could use NUDIST to sort large numbers of public comments, and of course they couldn't. And the first thing I learned working with Larry Brandt and people like Nosh at the Digital Government Program is you should team up with computer scientists because they have much better techniques for doing some of this work. And that's been a big influence on me, both the funding and the work, the cross-disciplinary work with the people in other fields. So the first set of slides I'm going to share with you are from a talk that I gave at Brookings recently. It was a panel on the future of e-rulemaking, which is the domain in which all of this technology was invented. So you might belong to an interest group like Sierra Club or the National Rifle Association. They might send you an email saying there's something very bad happening. You click on the link, you come to a form letter. That form letter can be edited or modified and sent on to the appropriate federal agency. And this is a big industry. Hundreds of thousands, millions of these communications come into the government every year. So this was sort of a group of lawyers and government officials and others who had gathered at Brookings to hear what the sort of state of the art was. And they asked me not to talk about the things that we'd already built, which most of them had heard about in previous talks, but to talk about the future. So the first couple of slides before I drop back in time is really about the future. Right? So from our point of view, where we're developing software, the future of projects is bright, right? And it centers around this idea of using credentials on the web as a way of validating who you are and controlling your access both to documents and to other people. Right? So what is a credential on the web? Well, I've got a couple of email addresses. I've got a .edu email address that validates me as an academic. Right? I've got a techsifter.com that validates me if you go look me up on the web as the CEO of a little software startup. I have a web page that's got a URL that validates me as working in various places. I belong to the American Political Science Association, and I'm working with them to build a prototype system to validate my credential as a member of the American Political Science Association. So you can think of credentials as things that are hardwired or things that could be self-asserted. I assert I'm an expert on e-rulemaking. There's nothing definitely that authenticates that, but credentials could be self-asserted, they could be hardwired, or they could be some combination of database queries and validations. Some of the tools we're working on take advantage of credentials to influence the way that you construct and carry out your searches over time, and hopefully to improve over time your use of credentials, metadata, your position in a network, and filters to produce a more advanced type of search, so that the search sort of accumulates information over time and becomes more intelligent. And just sort of leave you thinking about that for a while. But I'm sure anybody who studied with Nosh knows more or less what I'm referring to. There are powerful metadata out there, related to who we are in cyberspace, who we relate to, who we know, and how we interact with our data. And the tools that we originally built, the free open source coding analysis toolkit, or the newer Discover Text, which I'll talk about, are tools for labeling data. And so if you mix credentials in with labeling and search and tagging and do things in a kind of collaborative or even crowdsourced way, you start to open up new possibilities for analysis when the text collections are more than any one person could manage themselves. Ultimately, I run something called the Qualitative Data Analysis Program. A lot of qualitative researchers don't like what I do because it's got this sort of quantitative side to it, this number crunching side, God forbid, computer science side associated with it. But for some people, the mixed methods is the danger zone. For me, it's a sweet spot. Most people think of their documents, their data, their text data, as being associated with a particular application. It comes off a blog, comes out of a database. These are my Word documents, my PDFs, my spreadsheets, my PowerPoint. Well, we're encouraging people to think of as data independent of application that could be brought together to a unified repository where a project could be conducted with text from a variety of sources, irrespective of the origin of that. So it's sort of disentangling text data from the application in which it was developed. In the future, people will be in these iterative loops almost constantly, right? Sort of iterating on what they're searching for, how they're classifying it, where they're sending the reports, generating reports, sending the filters that can be developed based on earlier iterations of this search. So the future of e-discovery in text, and actually the reason I'm here in Chicago, the original reason, was to meet with an e-discovery law firm downtown Better Price, who are dealing with email collections that range from a terabyte to 50 terabytes of email that all needs to be classified. And a model like this is exactly what they're looking for to improve the ability to apply the right classification policies to big collections of text. Now, some of my favorite books, some of you may have read these books. The Jeff Jarvis book, What Will Google Do, has me thinking about converting our application into a platform. Right, a platform that, like Google, would allow other people to sit their applications on top of our platform, to take advantage of the architecture we're building to improve the quality of their applications over time. So this was just a fantastic book. I loved it and recommend it to anyone. And of course, the Weinberger book, Everything is Miscellaneous, talks about the way in which we've gone from thinking that everything has a proper place, think Dewey Decimal System and where a book goes under the Dewey Decimal System on the shelf, to the way we organize data now, which is there is no one proper place for a document, for a chunk of text. There are many proper places, depending your credentials, your background, your experience. You might put it in multiple places. And this is good, according to Weinberger, because it doesn't force us to find the one right place or the one right label for text. It allows data or text to accumulate multiple labels and then use that filtering and credentialing mechanism to pull back those bits and pieces of data on demand. And that's a nice step forward analytically. Tools we build in the lab and that we were funded by NSF to develop, for the rule writers, were tools that remove duplicates, that cluster near duplicates together. My work with Jamie Callan at Carnegie Mellon University, very important here for developing a prototype system that could be used by rule writers when they get 600,000 emails. And I'll say a little bit more about that. Automatically find the unique parts. We've started building tag clouds. I think they're kind of boring. Where the real future is topic models, where you can seed topic models, or the system can seed topic models, and you can see visualizations of topic models in large text data sets. And someday I'm dreaming of a big electronic display where I can touch screen and just have my topic models displayed and drag things in and out of different topics, refine the models, send that information back to the classifier, and produce a refined topic model over time. So there's a lot of work going on in that area, developing reusable topic models and shared systems of topic modeling so that you could accumulate social information over time about topics. Our architecture for the most recent versions of our software is sort of like a Facebook architecture. Some of the people who attended the training this morning set up an account and they send me a peer request. I accept their peer request. We're now connected through this web-based system, and I can now share data with them. I can assign coding to them. They can do the same with me. Part of what we're aiming to do with peer relationships is to build secure projects where data moves, across peer networks in ways that are a little bit different than think of the traditional way we do this. An organization, a university, an institution buys a software license. The only people you can share with are people who are holders of that license, right? So in the future, we want people to have a little more flexibility about how they build their cross-organizational, cross-agency relationships. At the heart of what we do, I'm a qualitative researcher. I label text. I feel very strongly about the role for humans in the labeling process. I meet a lot of people, I said this to the group this morning, a lot of people are looking for a magic button. They want to push the magic button and have the results come out and be done. If they had their way, their reports would be written as well for them by the magic button. Well, that's not really the way text analytics work. There's a real role for the human at the beginning and the middle and the end, and what we're trying to build are tools that reduce the burden on the human and scale up the potential of each human or groups of humans to do that work. But if you want to take the human all the way out, you need to bring a different speaker in. I'm really about keeping the human in the loop. I actually think the future of text analytics is one where, as Jamie taught me, you figure out what a human does better than a computer and what a computer does better than a human, and you build a system around that model. We had Professor von Hippel from MIT as a keynote speaker. The year after, we had Nosh as a keynote speaker at our yearly, I'm the editor of a journal called the Journal of Information Technology and Politics. We have an annual conference. Last year, Eric von Hippel came, and he blew my mind. He's just absolutely great speaker. The takeaway point, most incredible innovation comes from users, not from inventors. I'm an inventor. I don't know the best uses of my software. I always use the mountain bike example. It's a great one. Where do mountain bikes come from? A bunch of people dragging 10 speeds up of hills, destroying their 10-speed, riding it down a hill, and then telling the 10-speed company, wouldn't it be good if you had shock absorbers or other, reinforced struts or things like that. The same is true in text analytics. The way that we build models of text, the way that we interpret text, it can probably be done better in groups where there's a diverse set of viewpoints being brought to bear. And again, think about the role of credentials. Say I put my data out there in a publicly available repository, and I let 100 different people from 10 different disciplines do work on it. And then I can use the filtering mechanisms to look, what are people in government saying about this data? What are people in .edu saying about this data? What are people with PhDs saying about this data? And compare across those different credential types and build a more diverse analytic model on the backs of the work of all these different types of people. We're all web-based. We have servers in FSMA-compliant server rooms back at the University of Pittsburgh. We hire hackers who work for the Department of Defense. We deal with governments that are very cautious about cloud computing, and so we're constantly trying to have people tear down our system. It's very expensive to hire these people. They find vulnerabilities, they expose them, we patch them up, we wait for the next test when there'll be new vulnerabilities. It's part of the danger and the excitement of working in this space. It's a very challenging space to keep your data secure. And then this is the future, really, right? I've seen a number of presentations at conferences and other venues talking about the role of machine learning. For some people, machine learning is the magic button, right? But there is no magic button. I'm going to say that over and over again. But machine learning, right, can take the coding choices and the validations of humans and share them across a group, a project, a team, a set of teams, an organization, can produce results that can be fed back into the system. Active learning layer can be built, can activate, can produce better quality algorithms over time if you never throw away the decisions of humans. And this is what happens in a lot of research. Coding gets done, it's not reusable. It's not reincorporated into the model. Or if one team builds an active learning system and they generate data to improve the quality of their system, it's done. And they move on to the next project. And what we see the future is containing is systems that accumulate information over time and become smarter over time, more informed by the activities of users, and never throw away a human decision. It might not be useful in the future, but it probably will be. And we may not have even figured out the way in which that human decision is important. Now think of the genius of Google, right? The genius of Google is they look at every link and say that's a human decision. And they capture that information, they use it, and they reuse it, and use it again over time. And that was a kind of a breakthrough. Well, I think the same thing will be true with text analytics. So how did I get here? It's a funny jump back, right? But I got here as an undergrad by studying novels. I was an English major. I wrote a senior thesis on these two novels. And what was so good, this was a very good thesis, I was told, won the prize at Boston University for the best. Well, they were great books to start with. And what did I do with these books? I read them and reread them and read them again. I was not trained in text analysis or qualitative research or coding or anything like that, but I started marking them up, and I noticed emergent properties as I read and reread these novels over and over again. Certain character archetypes appeared in both books, like the law enforcement officer who exaggerates the nature of the threat to expand his own power and ability to accumulate resource and use resources in kind of nasty ways on the population. Even though these are very different books, there were 4 character archetypes that matched up perfectly in these 2 books. And so what I realized retrospectively was I was coding. Right? I was doing labeling, tagging. They were novels. I was working with highlighter pens and colored markers, but I was coding before anyone had taught me to be a coder. Same thing with, this is my data for my dissertation. Farm papers, urban agrarian magazines from the progressive era. I was studying how the federal government got into lending money to farmers, the Federal Farm Loan Act of 1916. So I would get these, big stacks of old crumbling newspapers wrapped in butcher paper, and I would pull them out. I'd go through every page, find every article that seemed relevant in any way at all, 1907 to 1916, to the issue of rural credit. And I would, discover through this immersion in text that there were certain properties of the text that were interesting. In part, it was about borrowing money. In part, it was about the profitability of farmers. A big thing I discovered by accident was that driving the farm credit movement was an interest in controlling the cost of food in the cities. That's why urban agrarians were, and I didn't go in looking for this stuff. It emerged from my spending a lot of time with the text, reading and rereading, doing the same thing that I did in my undergraduate thesis, and seeing the categories pop out, and then again manually labeling them. Right? So these 2 formative events, an undergraduate thesis and my doctoral thesis, sort of reflected a technique that no one had taught me. I'd been trained in grad school in econometrics and statistics and applied econometrics, but hadn't had a class on qualitative research through all of this stuff. And one of my mentors said, get the primary source data, spend a lot of time with the primary source data, and come back and talk to me in a month about what you found. He said, wow, Jerry, this is amazing. I spent a month, Jerry was my chair, I spent a month with this data, and I found things I didn't know were there, and I didn't know I was looking for. And that's one of the key insights of any qualitative researcher or grounded theorist, is that by spending time with your data as a human, not as a machine, right, and just ingesting a lot of it, things pop out. That inductive method, that grounded in the data method, is really very important to my whole way of thinking about the steps that come after you. Start speculating, coding, and then validating your findings. So if you skip forward, and after 10 years of working with people like Ed Hovey and Jamie Callan, and going to conferences, even conferences here on computational social science that have been incredibly stimulating, we're trying to do a lot of the same things, but we're trying to do them using machines that are fed ground truth data, or as close to ground truth as we can get from human annotators. So the laboratory that I developed and the techniques and software we developed originally focused on the task of feeding marked up data to professors of information retrieval and natural language processing so that they could develop machine learning algorithms that trained on our data. And it was very important from their point of view that we know how well a human can label data. And this is something we talked about quite a bit in the training session. If you give 10 humans the same task and the same set of labels, No matter how clear-cut you think those labels are, they're all going to interpret the task differently. And it's very important to have techniques and tools at your disposal that allow you to actually measure the differences between how different labelers will use these labels. So I mentioned I started my transition out of crumbly old newspapers and into digital text in the study of how this label came about. 277,000 people submitted comments to the USDA, and back then the methods for sorting public comments were very rudimentary. I mean, it was literally print it all out, no matter what form it comes in, and they had a fax machine going off, day and night, and stack the paper in a room, get a group of people in the room, and look at the shape of the words on the page and make piles. That was the state of the art when I started doing this work. I mean, we quickly found out that we weren't going to be able to use off-the-shelf nudist software to do this, that we needed more sophisticated tools. Why? Because groups like Convio and a whole range of actors in the political economy of public comment have generated very efficient ways of sending in mass mailings to people. This is one group that said this was a clicker they had on their page. It was constantly going 18 million constituent messages from one organization that's selling the service. So it's a subsector of the advocacy economy selling the generation of public comment for a for-profit basis and making a lot of money doing it and generating lots of comments. We entered into an agreement with the U.S. Fish and Wildlife Service, who've been big supporters of this work all along. They gave us some money to support the tech transfer. We had a prototype working in the laboratory, and we had to find some way to get that prototype out of the laboratory and into the government. And I mentioned at the start, this is a very difficult thing to do. Well, it helps when the Fish and Wildlife Service throws $250,000 in for a programmer to make it happen. That's what allowed us to do this, and we supported them, for $1.5 million comments. The big one being the polar bear. The chief marine mammal biologist up in Anchorage, Alaska, Charlie Hamilton, gets 600,000 emails about listing the polar bear as a threatened species under the Endangered Species Act. His job is really to count polar bears. That's his job. And suddenly, he's got to review 600,000 emails. Well, what's he going to do? Well, he's going to use our system. We're going to take all the duplicates out. We'll cluster the near duplicates. We'll automatically highlight the parts that are unique within form letters, so he can just go ding, 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 and find, in simple, plain truth, the 6 emails in 600,000 that he's legally required to respond to. All the rest of the emails are things like, I'm really sad. This is really depressing. I hate George Bush. These are the kinds of things people add to form letters. I've often said to my friends in the environmental advocacy, do you know what happens to your emails when they go in? When 500,000 emails came to EPA in 2004 on the mercury rulemaking, every one of them was printed on paper because that was the legal record. It didn't matter if it was a duplicate. They print them all up on paper, they sort them by the shape of the words on the page, they put them in boxes, and they ship them off to Maryland to store them forever and for always. I mean, it's crazy stuff, really. And if they found one that they thought was substantive, they did about 5,000 times, they scanned it in and created an image. So they started with plain ASCII text from email, converted it to paper, and the ultimate product was an image, which was unsearchable. Crazy stuff. To support this work, developed a laboratory, first at Pitt, now it's at UMass. It's operating still at Pitt. The lab is a little unusual. I've looked for peers across academia. I had to do a report to the provost. Couldn't find one. People don't sell coding. They do their own coding, or they put together a team of grad students. So it's a bit of a novel service. We invite people in. They're often quantitatively oriented researchers. Maybe they're funded by NIH or NIMH, and they've been told they need a qualitative piece. They've never done qualitative piece. They have no idea what they're doing. They come for us for help. We guide them through their project design, project management, their data management. We help them train coders, and we put the coders in place with a software system that supports a model that they understand is scientific, right? Which for most people, qualitative research and science are sort of like, like this. If you're doing qualitative, you're not doing science. You're doing science, you're not doing qualitative. So we put together a model of qualitative research that consistently was funded by NSF and other external funders as well, as being more of a hybrid of the two worlds. Kinds of projects that we work on. I mentioned this one this morning to somebody who is to you, right? I think this is Dr. Carpenter's project. We're coding focus groups, but we're also coding website content, and she's looking to see, in transnational advocacy arena, does what appears on the web, is it a good proxy for what the group says they actually. We did coding for improving the quality of optical character recognition, and here we developed just a simple little software system for looking side by side at the original scan and the text that the OCR produces, and for labeling all the mistakes. Turns out OCR is really bad at lots of things, particularly equations, tables, and other things like that. But there were some subset of the things that OCR is bad at that if we labeled them accurately, the company working on the OCR annotation software could improve it based on that labeling. In one of the more ambitious projects we did, I like to tell the story, was called over to CMU by Howard Wackler and a group of researchers working on this project. They sat me down in a big room with all the research team, about 25 people. They showed me a 3-minute video. In the video, a little old lady comes sort of trundling across an empty room to a man sitting in a wheelchair, and there's some sort of exchange that goes on between them. There's nobody else in the room, and then she starts to kick him, right? And she just keeps kicking him and kicking him and kicking him, and it kind of goes on so painfully long. It's sort of hard to watch. And then they stopped the video and they said to me, "How would you code that?" Well, what do you want to do? It really depends. I have some ideas. They said, well, we want to develop a sensor-based system to detect the precursors of aggressive or violent behavior. Okay. Well, and we start, talking about the different things that could be labeled and how to develop an optimal system, custom-built system, right, with foot pedals and stuff for reviewing all the video and labeling the verbal exchanges and labeling the physical body movements that happen in these short periods right before violent incidents. Now, this is a very long-term project. I don't expect that many nursing homes will have sensor-based systems in them anytime soon, but it's the kind of thing where the validity of the labeling is critical if the sensor-based system is someday going to work, right? And so there's actually a theme that runs through all of these projects where, you can label the data and measure the reliability of the labelers and get some information about the quality of your labeling that way. But if you don't know if those annotations are valid or not, you may be developing a baseline or a gold standard for your machine learning that is not going to produce a very effective machine. Working with some researchers on the Gale project while I was at Pitt, I learned probably the most important lesson about software development, which is why take something off the shelf which may or may not do what you want it to do when you could build something yourself that will do exactly what you want it to do. Right, so I watched these guys put up they looked at our off-the-shelf software we're using for labeling, and they said, no, that's terrible. Too much mouse work. We'll build, and in like a week, they put together an annotation interface. I was like, wow, this is a much better way to do labeling than Atlas TI or Nudist or any of those things. This is great. You guys are brilliant. I'm going to build my own software someday. That's exactly what I did, because I learned if you can tailor the software and the architecture of the software to the specific thing you're trying to do, which in our case was produce reliable and valid annotations, or at least the measurement of the reliability and validity of human observations, none of the software out there did that. So we had to build our own. This was and is the first piece that we built. It's called the Coding Analysis Toolkit. It's free. It's open source. It's hosted at the University of Pittsburgh. It's got close to 1 million coding decisions in it. 10 minutes left. Okay. The original purpose, right, was to measure the inter-rater reliability of observers and to adjudicate. We went over this in the training this morning. The adjudication module is really the key, right? Because you might put 2, 4, 6, 8, 10 coders to work, get back sort of raw measure of their inter-rater reliability, but then you want to dive in a little deeper and as a group or as an expert adjudicate the decisions and come up with a score. By coder, by code, by project. This is iterative reliability. It's good. It's useful for seeing how, oh, this coder uses this code just once. This coder uses this code 9 times. We have to talk to these coders about this code, right? Because it's not a 9-to-1 ratio is not acceptable if you're, over time. You've got to understand how coders interpret the code scheme, how they use it in practice, get a measurement in raw counts and the slices kappa, but then go through and adjudicate those pre-tested coding schemes and see. So this is the adjudication module back in CAT. This is an item that was coded. That's how it was coded. You see the different coder score. You adjudicate valid, not valid. And the system stores that information. The way we used to do it was pen and paper, and then we'd go back into Atlas TI and remove all the false positives. It took forever. Big waste of time. Here now we accumulate data over time, not only about a project, right? A project validity score, coder validity score, a code. You see here, look, every time magnitude of problem code is used in this pretest, it's used in an invalid way. Incredibly useful information, right? From the point of view of the project director or the team that's running the project. If you think your codes are transparent and self-evident, can be used by coders, one of the things that adjudication tells you is they are not. Right? You can feed that information back in, and maybe Kendall needs more training than Emily. Maybe Kendall needs to work on a different project, something like that. And maybe we need to have discussions about things that are half the time being used in invalid ways. So for all the things we've invented over the last 4 or 5 years, I would say that this page is probably the most important page in any project because it tells you the most about the validity of the observations that your coders are producing. The newer version of the software takes more data types. I'll just skip through this. It has more automated features for our rule writer friends in the government. It has the architecture of the peer relationships that I mentioned at the outset of the talk. Collaborative, some automated, some human work. Ultimately, what I want to do is improve the quality of human judgments, figure out where human judgments add the most value to a project. Like say I've got a machine classifier running on some data, and it's got some slam dunk decisions where it knows exactly where to put that data, and it's got some decisions where it's not quite sure. It's a toss-up. Well, having a human adjudicate the slam dunks is a waste of time. Having the human adjudicate 50 decisions where the classifier is confused is incredibly valuable. So to the extent you can isolate the places where adjudication adds the most value and increase the ease with which the adjudicators add that value to a project and reincorporate it into the machine classification or the code book or the overall approach to the study, you're making progress. Some of the data we're dealing with, big dumps off regulations.gov, massive downloads. We just got 100,000 emails off of Lotus Notes from the Fish and Wildlife Service. We ran the deduper. We got their pile down to under 9,000. We ran the clustering tool. We organized it all, highlight all the unique text. What was 100,000 emails in one person's box becomes about a little less than 9,000 coding decisions, where the rate of decision will probably be in the order of 1 to 5 decisions per minute, kinds of modifications in the emails. Obviously, we're looking for new sources all the time. We work with Chirag Shah, student of Gary Marchini. He's now a professor at Rutgers. He's real good at developing tools for scraping like Context Miner or Info Extractor. Take content off blogs, bring it more easily into our software, content off of YouTube as well. When there's a lot of views and a lot of comments, you can use a tool like the Info Extractor to pull that text off, flatten it out as plain text or XML, and then feed it into our system very easily for coding. The overall architecture, take lots of documents, bundle them up, bring them into PCAT to CAT to discover text, ease the process. Use search, right? This is the Afghan war diaries, 76,000 reports from the field. Use search to find subsets of your total archive, convert those subsets, which we call buckets, into codable data sets. That's the workflow. And then the coding that we do, our workflow is stay off the mouse as much as possible. So items should load to this is like a unit of text to be coded, a very simple coding scheme. The user controls the coding scheme. It's linked to keystrokes. Item loads, code it. Item loads, code it. Item loads, code it. You can do a lot of items quickly. This is the deduplication. Start with almost 10,000. Remove the duplicates. We're under 3,000. Cluster them automatically. And then this is the kind of highlighting we do. These are modified form letters. And you can see the kinds of, yellow is edits. Blue is unique text. This is an unusually large amount of text to be added to a form letter. Most of them look more like this. People will add a sentence here or there. This is our dirty word list. These are some of the tamer. We have 220 dirty words in our list. And you can modify that dictionary. We're working with FOIA officers and declassification officers and federal agencies to build a workflow where there are certain things they need to redact before they make documents public. That's the proper way to make documents public, whereas WikiLeaks is the improper way, in my opinion, to make documents public. That WikiLeaks data set I showed you, I mentioned this in the other training, I can find the longitude, latitude of all the informants and sources reported in those 76,000 documents in a couple of hours. Easy. Probably less than an hour. Drilling in through, these are tag clouds, should be very familiar to most people. Ultimately, these will be topic models that are dynamic and manipulable by users working in teams. Discover Text is our newest software. That's what we were training on this morning. You can ingest feeds from Twitter, from Facebook, a whole range of sources for analysis. You've got to go through this nasty little set of permissions to do it. Probably most of you are familiar. If you're not, we describe all this on the help page for Discover Text. We built our own little opt-out page as you're registering for an account. So you can, this is what the Graph API from Facebook gives us access to. You can opt out of all that stuff, but then you've ultimately got to click on all the blue allow buttons or you can't do it. You can log in with just a regular old username and password and avoid all the Facebook stuff. You just can't scrape Facebook. Got to have a Twitter account to scrape Twitter. Much less daunting credential process here. But what we want is a system where data can come from any source, any database, any blog. We have a bulk ingest. If you've got a WordPress blog, the owner of the blog can do an XML export. One of the sample data sets on Discover Text is from Climate, etc., where the owner of the blog was more than happy to export the entire blog content as an XML file and give it to us as a sample data set. What we want in the future is for all bloggers to be able to hit one button on WordPress and send their stuff into a common pool area for analysis, right? We've done lots of scraping and RSS feed capture, and we talked this morning about the idiosyncrasies of RSS feeds and the capturing tools. It'd be much better if people just gave us their data rather than forcing us to go out and get it. All these data types will be part of the future. This is the redaction. There's a start of our dirty word list. People like to see that, so I'll just click back for 1 sec. It gets worse. How do we generate this list? We crowdsourced it. I put up a spreadsheet on Google, I made a form, and I sent a listserv, a couple of notices, send us your dirty words. We had 500 submissions in a week. They are disgusting. And then we had to end up like looking stuff up on Urban Dictionary to see, is this really a dirty word? I've never heard of it. A lot of stuff we had never heard of. The important thing about this, though, is this is a global dictionary available for redaction, our redaction toolkit, but you're going to be able to create all sorts of global lists, sentiment lists, other kinds of dictionaries that will be modifiable, to be shareable. So I might develop a sentiment dictionary for a particular domain. I might want to make that public. Other people might want to modify it, add to it, refine it. What we're trying to build is an architecture where the social side of text analysis is really played out. We can find the addresses, social security numbers, stuff like that, black them out, eliminate them. Last slide. We're working in the cloud. This has been a real challenge for us. Some of our potential customers are the DHS, the Secret Service, and agencies like that that are very sensitive about working in the cloud. Even an agency like the Department of Agriculture, will be very cautious about the prospect of doing this kind of work in the cloud. But everybody's there or getting there, and soon we'll all be in the cloud together. Thanks.
We have about 5 minutes.
Yes.
Speaking to that a little bit.
absolutely. Right. Well, this is one of those things where I would say the user probably. Oh, okay. The question is, my early allusion to the use of credentials for access to documents might result in a certain bias. Right. What I would say is bias is independent of technology. Right. People's biases exist because they're biased. So I might be biased to people with PhDs. Right. Now the technology that allows me to differentiate coding done by PhD holders versus non-PhD holders is not in itself biased. It's just technology, right? It's a filter. And how I choose to apply those filters is really up to me. I expect that you will come up with a way, if you choose to do so, of using credentials that conforms with your preferences, right? So if your preference is for unbiased, you're not going to leverage those credentials as a filtering mechanism. But if your preference is to compare what people with different socioeconomic status, different web presence, different credentials in academia or in government say, like one credential that strikes me as important, I know a guy named Jeff Lubbers. He is the #1 scholar of administrative law. He's a good friend of mine. And if Jeff Lubbers is going to get on to Discover Text and mark up, I don't know, say we're coding the new healthcare law, and he marks up 6 passages, and I can filter down to just things that Jeff Lubbers has marked up in a big data set, to me that's very useful. Does that mean I'm going to dismiss everybody else's annotations as useless? No, but I may weight my interpretation of the value of someone's annotations by the same token. I might want to control who has access to my data. Right? I might want to say anyone at Northeastern, anyone with a northeastern.edu can have access to this data set. But I don't want anybody at the University of Illinois Chicago to have it. Now that's a stupid example, but you can see that the uses of credentials are not inherently biased. It's the decision that, and the preferences of the user that would introduce bias. What we're trying to create is a system that's flexible, right, where the uses aren't all designed by the inventor, right, where you'll say, oh, well, these credentials are interesting, but I would use them for something completely different. And that's the goal, is that the tool itself not be a purveyor of bias. And obviously bias is something that we want to be aware of. And because, I mean, this comes up in coding all the time. People get their 2 grad students trained, or their 2 undergrads, or their 4 undergrads trained. They do all their coding. And they act as if those 2 or those 4 coders are somehow, you know, the right coders. Well, I can tell you they're not. I can tell you they're just 2 or 4 out of a potential million of coders that are out there. And the traditional way of thinking about it is you get 2 coders, you do your coding, maybe you overtrain them, maybe you undertrain them, you don't know. Because there's no actual science of overtraining and undertraining, right? But if the disruption is if you create the possibility for 100 coders and use the credentials as filters to pull back the data in different slices and then compare it and see, wow, I can actually learn a lot from non-PhD holders at the University of Illinois Chicago. Well, I'm not concerned about that. I think it's useful to have a basis for judging where your coders sit in the universe of potential coders, right? That the old model of coding is kind of bankrupt. It really is. The idea that you could pull the 2 students out of your grad class that are the right people to code your data, and that their observations that you can iterate reliability, adjudicate the difference, do all that stuff, and then you're going to end up with the valid coding is a fallacy. It's a version of annotation, of thousands of potential versions of annotation. And where I think this gets interesting, following von Hippel and the crowdsourcing ideas, as you scale it up, and you see how people in other countries, in other disciplines, with other backgrounds are coding the same data. I mean, we're all interested in what Obama says about Egypt. But how is this interpreted around the world? How are news organizations, when Reuters puts out a story and people in Egypt look at it, what do they think versus what people in the U.S. say? It's just more hooks into the data. At least think outside the box. Yeah. So thank you very much for having me. It's been a great honor to be here. I've enjoyed it thoroughly.